Inshallah, in this class, we are going to continue EAMCET limits. So before going to the next concept, let me have a real discussion about the limit extends to. Suppose we are having some number line. Suppose there is a values. For instance, suppose we are having 2 here. So suppose 1 here, 3 here. Now watch here. When we say extends to 2, see here, we suppose this extends to 2 from the left side or right side. Now if you say extends to 2 from the left side, so if you go from here, it will be slightly less than 2. Suppose 1.999, 1.998 like this. So when we say limit extends to 2 from the left side, we note this by minus. What does it mean? Extends to 2 minus means slightly less than 2. Slightly less than 2. Slightly less than 2. So left hand limit means extends to 2 minus. That means slightly less than 2. Whereas if you go from right side, we say right hand limit. So when we go from right side, we feel slightly more than 2. Suppose 2.001, we consider slightly on the right side, little more than. So we write like this, extends to 2 plus. So extends to 2 minus means we are going to the limit extends from left hand side. 2 plus means right hand side. 2 plus means little more than 2, and 2 less than means little less than 2. We can use this symbol also, extends to 2 minus delta, or extends to 2 minus 0. We can use these symbols also. For right side, extends to 2 plus delta, or extends to 2 plus. This all means the same. Okay, so the limit exists only if both values should be same. Watch carefully. So we are going to start from here. A limit exists if left hand limit is equals to right hand limit. So limit extends to a minus and limit extends to a plus. If both values are same, then we say limit exist at x equals to a. At x equals to a. And next thing is, when the function is continuous, we have to see this. There should be 2 3 conditions for this. For a function to continuous at suppose a, point A, so first thing is the limit should exist at a, that is left hand limit should be equals to right hand limit. Just now I have seen here left hand limit and right hand limit should be equal, that is the limit should exist at x equals to a. Second thing, the value of limit extends to a f of x, and the value of the function at a, that is f of a, this two should be equal. The limit value and f of a value, these two values should be equal. Limit extends to a f of x value, and the value of the function at a, f of a, these two should be equal. They should exist and should be equal. Then we say limit is continuous at x equals to a. At x equals to a. So let me do one thing. Now you revise once more. For continuous, the limit should exist at a point A, and the limit value and the function value should be equal. Okay, so let me start with one question here. Watch carefully. We have already done 20 questions in the previous classes. Now see here, if the function is continuous, already it is given that the function is continuous, so the limit value and the function value should be equal. If the function is continuous, then what is the value of f of x at x equals to 0? That is, he is asking the value of f of 0. F of x at x equals to 0 means f of 0. We know that because the limit is continuous, the function is continuous, therefore f of 0 and the limit at x tends to 0 should be equal. So let me find the limit at x tends to 0. This value and f of value should be equal. So let me find this value, 4 tan x by x. Now you do one thing, separate this one. Limit x tends to 0, we can write like this, 3x by x plus 4 tan x by x. This 3 will get cancelled. So limit extends to 0, 3 will be constant 3 only. Okay. Now this, we know the formula, limit extends to 0, tan x by x is 1. So we can write this 3 plus 4 into. Here is constant, you write as it is, plus 4 into. Limit extends to 0, tan x by x is 1. We already seen this formula, tan x by x, limit extends to 0 is 1. So 4 plus 3 is 7. So the limit value and the function value at x equals to 0 will be same, because it is continuous already given. So therefore its value will be 7. So I think, just wait, actually answer is 7. I think I wrote this wrong here. Suppose this has 7. So let me do one more question. You see here what's on the board. Next question. Now see here, f of x equals to 2x minus 1 if x greater than 0. If x greater than 0, its value is k if x is equals to 2, and its value is x square minus 1 if x is less than 1. Okay, so x is less than 2 is continuous. Then find the value of k. We know continuous means, just now we have seen the value of limit extends to a, f of x is equals to f of a. Let me use this concept. Now see here, its value is k at x equals to 2. That means f of 2 equals to k. F of 2 equals to k. F of 2 equals to k. Now see here, let me do one thing. So let me find the limit. Already it is given, it is continuous. That means this always is equal. I am doing that. Limit x tends to 2 plus. I am taking this plus. For right hand limit we take plus. X greater than f of x equals to f of 2. F of 2. Just now we have seen the limit value at this and the function value should be equal. We can take this also, we can take this also, because it is continuous, it will be equal. So let me go here, watch carefully. X tends to 2 plus means slightly more than 2. So which we have to take from this 3. X tends to 2 plus means slightly more than 2. So we have to take this for f of x. So limit x tends to 2 plus. We are using this one because this is x greater than 2. So this x tends to 2 plus means greater than 2. F of 2 value is k. Now you substitute value of x as 2. 2 2s are 4. 4 minus 1 is 3. So 3 equals to k. So the value of k is 3 here. You see the next question. F of x equals to cos 3x minus x by x square for x not equals to 0, yani tends to 0. And the values, one more value is lambda for x equals to 0. That is f of 0 equals to lambda. F of 0 equals to lambda. This is 0. So f of 0 equals to lambda is continuous. Continuous means the f of 0 and the limit value at x tends to 0 should be equal. So let me find this value, limit x tends to 0. That value will be equal to lambda. So question is then lambda equals to dash. So the limit value will be equals to lambda. So let me find the limit here. Watch how to find the limit. Limit x tends to 0, because we have to see at 0. Now you see this as c, this as d, cos c minus cos d. We know cos c minus cos d is, we can use this formula as 2 sine c plus d by 2 sine c minus d by 2 divided by x square. Now let me solve this one. Minus 2 is constant, we can take outside. Limit x tends to, see here, 3x plus x is 4. 4 by 2 is 2x. Sine 2x by this x square, I am writing 1x here and 1x with this one. 2x minus x is x by 2. X by 2, sorry, sine x by 2 divided by 1x square, I wrote here 1x and 1x I am writing here. Sine c plus d by 2, sorry, minus 2 sine c plus d by 2, sorry, here 3, no, sorry, 3x minus x is 2x by 2 will be x. So we know this formula, sine, limit x tends to 0, sine x by x is 1. So this will become 1, this will become 1. Okay, now limit x tends to 0, sine x by x is 1, but here you are having 2x now. Here should also be, you must have 2x. You are already having x. To bring 2 here, multiply and divide by 2. Divide by 2 and multiply by 2. Let I am multiplying here. So this will be minus 2 2s are 4. Now this is sine x by x is 1. Sine x by x is 1. So this will be minus 4. Now see the next question, same type of question. This function is given continuous at x equals to 4. Then what is the question? This is at x equals to pi by 4. That is f of pi by 4 is given as a. So how to find a? To find the limit value. The limit value and function will be same. So let me find the limit value of this. Limit x tends to at pi by 4. Limit x tends to pi by 4. 1 minus root 2 sine x divided by pi minus 4x. Now if you substitute pi by 4, 4 will be cancelled, pi minus pi 0. And sine 45 is 1 by root 2 cancel. This will be 0 by 0. So let me use the L'Hospital rule. Let me differentiate the numerator and denominator. Limit x tends to pi by 4. If you differentiate numerator, this is constant 0. We already discussed in the previous class, if we are having 0 by 0, we must differentiate numerator and denominator separately. Then again we have to substitute the value. 0 by 0 is indeterminate form. You see the previous parts, you will get the knowledge there. So d by dx of sine is cos. So this will be minus root 2 cos x divided by pi is constant 0. D by dx of x is 1. 1 into minus 4, minus 4, minus 4, 4 will get cancelled. So minus minus. Now if you substitute pi by 4, 45, this will become root 2 into sine cos 45 is 1 by root 2. By this is 4. Root 2 will get cancelled, get 1 by 4. We'll get 1 by 4. Now see here, f of x value is for less than 0, this value, and for greater than 0, this value is continuous. Then k equals to dash. Let we use for less than 0 means left hand limit, and for greater than 0, right hand limit at 0. So because this is continuous, let we equate this line. Limit x tends to 0 minus f of x, that is left hand limit, will be equals to right hand limit. Limit x tends to 0 plus f of x. So with this condition, let me find the value of k. So limit x tends to 0 minus means slightly less than 0. So slightly less than 0 means we have to use this one for f of x. Under root of 1 plus kx minus under root of 1 minus kx divided by x equals to limit x tends to 0 plus 0 plus is slightly greater than 0. So let me use this form 1, 2x square plus 3x minus 2. Now you see here on the right side, if we directly substitute this value 0, this will be 0. Root 1 minus root 1 will be 0 by 0 in intimate form. So for intimate form, what we are doing, we are differentiating and using L'Hospital rule. Now d by dx of root x, we know 1 by 2 root x. Now internal differentiation is constant 0. D by dx of x is 1. 1 into k is k. In the same way, minus d by dx of root x is 1 by 2 root x. Now if you differentiate internally, 1 is 0 constant. D by dx of x is 1. 1 into minus k, again minus 1 is, this will be plus k. Equals to, now let you substitute 0 here. 2 into 0 plus 3 into 0 minus 2. You left with 0 minus 2 here. Now let me substitute 0 here. This will be 0. 0 plus 1, 1. Root 1 is 1. 1 2s are 2. So this will be k by 2 plus. Again, this k into 0 is 0. 0 1 minus 0, 1. Root 1 is 1. 1 2s are 2. This is k by 2 equals to minus 2 by 2. K by 2 plus 2k by 2 will be 2k by 2 equals to minus 2. 2 will get cancelled. So what is the value of k? The value of k is minus 2. Now see on the board, let me recall this. We know the first principle to find differentiation. First principle to find differentiation is f dash x equals to limit h tends to 0, f of x plus h minus f of x by h. In the same way, we can use this formula. F dash a equals to limit x tends to a, f of x minus f of a divided by x minus a. Now see here, let me solve one question. What is given here? F of x equals to x minus 2 divided by x square minus 3x plus 2. And its value is 2 if x equals to 1. Its value is 1 if x equals to 2. Then the question is limit x tends to 2. F of x minus f of 2 by x minus 2. I am doing like this. You see here. This is actually formula. Not to go in detail. We can use this as f dash 2. Limit x tends to a, f of x minus f of a by x minus a is f dash 2. So let me find f dash 2 from here. You see here, f of x equals to, I'm writing like this, x minus 2 by, you factorize this one, x square minus 3x plus 2. 2 ones are 2. This is minus 2. You know, factorization, x square minus 2x minus 1x plus 2. Take common here x. It will be x minus 2. If you take common minus 1 here, it will be x minus 2. So what you'll get here? X minus 2 into x minus 1. So cancel this one. So the f of x is 1 divided by x minus 1. So let me differentiate this one. We know d by dx of 1 by x is minus 1 by x square. D by dx of 1 by x is minus 1 by x square. In that way, if we differentiate f dash x, d by dx of 1 by x is minus 1 by x square. Now let me use f dash 2. In place of x, you keep 2 here, 2 minus 1 whole square. This will be 1, minus 1 by 1 will be minus 1. Now see here, f of 2 equals to 4, f dash 2 equals to 1. We have to find limit x tends to 2, x f of 2 minus 2, f of x by x minus 2. We can do by using El Hospital rule also, but I am doing with different method. You see here, limit x tends to 2. I am doing one thing, x f of 2. If suppose we are having minus 2 f of 2, then we can take common from here f of 2. So to bring minus f of 2, you subtract minus 2 f of 2 and you add 2 f of 2. What is left here? Minus 2 f of x divided by x minus 2. What we did to change into the formula, I did subtract and add 2 into f of 2. Why? We can take common from this 2 and we can take common from this 2. Now watch here, limit x tends to 2. If you take f of 2 common from this 2, what is left here? If you take f of 2 common here, it is left with x. It left with minus 2. Divide, let me separate this one, x minus 2. Plus now let me take common from this 2. I am taking minus 2 common from this 2, minus 2. Okay, now limit x tends to 2. If you take minus common, this will become plus, this will become minus. So this will be f of x minus f of 2 by x minus 2. I separated the denominators, watch carefully. What we did, from this 2, if you take f of 2 common, you left with x minus 2 by I separated the denominator. From this 2, I am taking minus 2 common. If you take minus common, this will become plus, this will become minus. You add the same denominator here also. So here you cancel this. Now f of 2 is a constant function. Take out the limit f of 2 minus 2 into, just now we have seen limit extends to a f of x minus f of a, sorry, this is f of 2, sorry, f of x minus f of a by x minus a is f dash a, that is f dash 2. Now the value of f dash 2 is given in the question as 1 and f of 2 is given as 4. F of 2 is given as 4 minus 2 into f dash 2 is in the question is given as 1. So this will be 4 minus 2 is 2. See here, f of x equals to this for x less than 0 or equal to 0, and this for x greater than 0 is continuous. So we can take left hand limit equals to right hand limit at x equals to 0. So limit x tends to 0 minus is left hand limit, f of x equals to limit x tends to 0 plus f of x is right hand limit. Because it is continuous, so limit exists, that is left hand limit, right hand limit equal. So limit x tends to 0 minus 0 means minus means less than 0. So for less than 0 we have to use f of x, this one, a square cos square x plus b square sin square x equals to limit x tends to 0 plus means this one. So let me use ax plus b. Now let me substitute the value of 0. So sin 0 is 0. What is left here? Cos 0 is 1. 1 into a square is a square. If we put a 0 here, a into 0 is 0. You left with a power b, e power b. Let you do one thing. Apply log on both sides. So this will log of a square mod equals to log of e power b. Bring this b here. Log e is 1. So bring this 2 here. We can write like this. 2 log of mod a. I'm using mod because log negatives are not defined. If you bring this b here, it will be b log e, and log e is 1, so what is left here? B. So b equals to 2 log mod a. Now see the next question. Given this is f is continuous. Continuous means limit value and function value at phi should be same at x equals to 5. So f of phi is nothing but limit x tends to phi f of x. Since it is continuous, therefore limit value at phi and f of phi should be equal. So we have to find f of phi. That means let we find the limit at phi. Limit at phi. So see here, let me find limit x tends to phi. If you add substitute phi square 25 plus 20, 50 minus 50 is 0 by 0 it will be. So let me differentiate El Hospital rule I am using. If differentiate x square, it will be 2x minus x is 1, d by dx of x is 1 into 10 is 10, constant 0. X square is 2x minus 7. Okay. Now you see here, if you again substitute 2 here, sorry, this is 2x minus 7, 2x minus 7. If you substitute again 5 2s are 10, 10 minus 10 0, divide by 2 5s are 10, 10 minus 1 is 3. So 0 by any number is 0, this is not independent, this is 0 by 3 is 0. So f of phi will be same as the value of limit, so limit value is 0, therefore f of phi will also be 0. Now see the last question. See here, f of x equals to x plus 2 by x square plus 3x plus 2. if x belongs to r minus minus 1 minus 2. You see here, for all the values this will be finite except minus 1. If you keep x minus 1, this will be 0. Any number by 0 is infinity, so this is minus 2 also. So let me do one thing. What is given at x equals to minus 2, its value is minus 1. That is f of minus 2 equals to minus 1. F of minus 2 equals to minus 1 and f of minus 1 equals to 0. So at this 2 point, let me see the function value and limit value will be same or not. If the function value at 2x tends to minus 2 and limits is same, then we say continuous. In the same way, x tends to minus 1, we find limit value. If its value is 0, then we say it is continuous. For that, let me do one thing. You factorize this one, x square plus 3x plus 2. 2 ones are 2. If you factorize this you will get x plus 1, x plus 2. Let me substitute this one, limit. Let me first see at x equals to minus 2. So limit x tends to minus 2. This you can write like this, x plus 2 divided by this. You can write as x plus 1 into x plus 2. Now x plus 2 cancel. If you put x equals to minus 2 plus 1 minus 1, 1 by minus 1 is minus 1. And the limit value is also same. That is, it is continuous at x equals to minus 2. In the same way, let me see at x tends to minus 1. Limit x tends to minus 1. So see, once more I am writing x plus 2 divided by this is x plus 1, x plus 2. You cancel this one. If you keep minus 1, this will be y minus 1 plus 1, 0, infinity. So any number by 0 is infinity. But what is given? The value of the function at minus 1 is 0. So these two are not equal. That is, it is discontinuous at x equals to minus 1. So we can say it is continuous at all real numbers except minus 1. So r minus minus 1. It is continuous for all other values of x except minus 1. So therefore real numbers minus minus 1. So we have done few questions based on this continuity and the existence of the limit. Okay, let me continue in the next class with some more typical questions, inshallah. I request to like, share and subscribe my channel.